Hello everybody, welcome to Vysh IAS. This is Pranay and we are going to continue the Geography class 11th textbook Fundamentals of Physical Geography. I request you to like this video, share with your friends and please leave a one-liner comment so that we know how many people are really attending the classes, as well as it will encourage us to put more free content on the YouTube. And please reach us on WhatsApp. The number is provided here. And if you need any sort of coaching material, any sort of test series or any information, please reach us on WhatsApp. So we are going to start the unit 4, the climate. Previously we have completed till the chapter number 7, and we are going to continue with the chapter number 8 from today, and this comes under the unit number 4. So what exactly is in unit number 4? First thing, we are going to see about the atmosphere. So what are the compositions and the structure of the atmosphere, as well as elements of weather and climate. So atmosphere plays very important role in the life basically, and whatever is happening on the earth is very dependent upon the atmosphere. Next is insolation. What exactly is insolation? Is basically the input of solar energy towards the earth basically. Okay, so angle of incidence and distribution, heat budget of earth, heating and cooling of atmosphere, temperature, factors controlling temperature, distribution of temperature, and horizontal and vertical distribution of temperature and inversion of temperature. Then we are going to see the pressures. What are the pressure belts? And most of the climatic things will be cleared with these chapters basically. And then we will see about the precipitation, what kind of rainfall we have, what kind of precipitation we have, including the evaporation and condensation cycles, and distribution of rainfall throughout the world. And next comes the world climates. So what are the classification, what are the greenhouse effects and global warmings and climatic changes. Okay, so most of this thing you might be seeing in the environment also, but we will be seeing in the geography perspective. So we shall start with the chapter number 8, composition and structure of the atmosphere. So what exactly is atmosphere? Atmosphere is composed of gases, water vapor and dust particles. The proportion of gases change in the higher layers of the atmosphere in such a way that oxygen will be almost in negligible quantity at the height of 120 kilometers. Similarly, carbon dioxide and water vapor are found only up to 90 kilometers from the surface of the earth. See, for example, you can consider, if you consider this as earth, okay, there is a thin layer of envelope around the earth, okay, which consists of all different kind of gases as well as water vapor and dust particles. What exactly is atmosphere is basically this envelope which encloses or which envelops the earth. Okay, so this plays a major role in our livelihood, as well as most of the communication being happened, okay, on the earth is because of this thing. Okay, we will see gases. So what kind of gases are present in the atmosphere? Carbon dioxide is meteorologically a very important gas, as it is transparent to incoming solar radiation. So I guess you might have already studied like what are the gases present, and what kind of proportion the gases have, like nitrogen is there, oxygen is there, and nitrogen is the highest proportion. These all were completed in the previous classes. You can attend them. Okay, carbon dioxide is one of the major gases. Okay, very important gas as it is transparent. Okay, transparent to the incoming solar radiation, but opaque to the outgoing terrestrial radiation. Okay, for example, if we consider, this is sun and this is earth. Okay, when the sun radiation is there, the wavelength is different when enters the atmosphere. Okay, when it enters the atmosphere, the wavelength is a lot different. Okay, there is a difference in the wavelength. When it enters inside the earth, it passes through this atmosphere. which in which there is ozone layer also, as well as different gases, and this ozone layer all cut down the UV radiation and very harmful different kind of radiations. And after that it reaches the earth releases some sort of heat, okay, because it gets heated up and it releases it in a different wavelength, okay. But in this wavelength it doesn't move out of this atmosphere basically, okay. It doesn't move out of this atmosphere because of the wavelength difference. So what happens is it hits here and it scatters from here, reflects back and scatters from here, which causes the temperature to be warm, basically the Earth's temperature being warm. If the atmosphere not if this atmosphere was not there, because of this harmful radiation also we were affected also, and this reflecting heat will also go out completely. So there is a chance, specifically in the nights when there is no insolation or there is no solar input, basically automatically we will be in a position to getting into extreme temperatures, okay. So there will be extreme temperatures. So because of this thing only we are able to survive basically, okay. So and reflects back some towards the Earth's surface. It is largely responsible for the greenhouse effect. This is the greenhouse effect which we are talking. You will see in the coming slide. The volume of other gases is constant, but the volume of carbon dioxide has been rising in the past decades, mainly because of the burning of fossil fuels. This also has increased the temperature of the air. See, for example, carbon dioxide is very important. We totally understood that. But excess of the same carbon dioxide, see, previously when there were no industries were not there, this coal related power production was not there, usage of fossil fuels such as petrol and all was not there, then oxygen and carbon dioxide balance was there. Like the way the carbon dioxide was being produced was because of the human beings, and the same thing was being absorbed by the plants also. So there was a kind of a balance. But now, because of this fossil fuels, industries, coals and all that, the CO2 level is increasing tremendously, which is causing this global warming, okay. So one of the major concerns of the COP26 meeting, maybe remaining all the environmental related meeting, the Paris agreements, these are related to the greenhouse gases basically, okay, which are short formly called as GHCs. So this is greenhouse effect. See, the sunlight is reaching Earth and slowly this is releasing the, okay, in form of heat basically, okay, greenhouse gases, and then radiated in all directions, warming the Earth, okay. So this is basically the greenhouse effect, okay. You can see, okay, then energy is reflected back into the space and it is absorbed and as heat. Most of the heat is absorbed by the greenhouse gases and then radiated in the all directions, warming the heat, okay. Ozone is another important component of the atmosphere, found between 10 to 50 kilometers, okay, above the Earth's surface, and acts as a filter and absorbs the ultraviolet rays radiating from the sun and prevents them from reaching the surface of the Earth. These ultraviolet rays are very harmful for us, for the eyes as well as the skin, okay. So this ozone layer is protecting us from the ultraviolet radiation, the harmful ultraviolet radiation. But this ozone, because of the CFCs, chlorofluorocarbons and HFCs and all that, this ozone is getting depleted. The thickness of the ozone layer is getting very thin, and at a couple of places the ozone has completely depleted also. So because of that itself, the CFCs and HFCs are major concern. You might have read it in the environment book, okay. Next comes the water vapor. Water vapor is also variable gas in the atmosphere, which decreases with altitude. So as the altitude is increasing, okay, water vapor will be decreasing basically, okay. In the warm and wet tropics, it may account for 4% of the air by volume. while in dry and cold areas of desert and polar regions, it may be less than 1% of the air. So where there is warmth and wetness, automatically the water vapor will be high. Okay, and when there is dryness and cold areas, it will be low, and specifically in the dry and cold areas of deserts as well as polar region. Water vapor also decreases from the equator towards the poles. Okay, it also absorbs parts of the insolation from the sun and preserves its radiating heat. Okay, it also is useful for protecting the heat basically, from what do we call, like losing the heat basically. It will protect us from losing the heat. Okay, in thus acts like a blanket, allowing the earth neither to cold nor too hot. Water vapor also contributes to stability and instability in the air. Okay, next comes the dust particles. Okay, atmosphere has a sufficient capacity to keep small solid particles, which may originate from different sources and include sea salts, fine soil, smoke soot, ash, pollen, dust, disintegrated particles of metals. So whenever you see, specifically in the cities and all that, when you see up in the sky might not be very clear. Okay, but when you go to some remote areas where there is no pollution, where there is no dust and all that, you may see the sky as very clean thing. Okay, specifically when you go nearby Himalayas and all that, because of the altitude as well as no pollution and all that, you can see the sky as very clear basically. Okay, so this dust thing is one of the major part of the atmosphere. Okay, are generally concentrated in the lower layers of the atmosphere, yet conventional air currents may transport them to greater heights. See, what air current is basically, the heat and cold air is what exactly is air movement? Heat and cold. The heat will move towards the cold will move towards the heat. This is what a specific current is basically. Okay, the higher concentration of dust particles is found in subtropical and temperate regions due to dry winds in comparison to equatorial and polar regions. Dust and salt particles acts as hygroscopic nuclei around which water vapor condenses to produce clouds. Okay, so we will see the structure of the atmosphere now. The atmosphere consists of different layers with varying density and temperature. Okay, so there are different layers with varying density as well as varying temperature. So as the layer changes, there will be change in the temperature also. Okay, density is highest near the surface of the earth and decreases with the increasing altitude. As the altitude is increasing, the density will decrease. Okay, the column of atmosphere is divided into 5 different layers. Okay, so first is troposphere, which is very nearer to us. Then comes the stratosphere, then comes the mesosphere, then thermosphere, and the last is exosphere, which is the extreme basically. Okay, we will see in detail. Okay, so you can see this small animation kind of a thing. So this is troposphere basically. Troposphere contains all the major clouds as well as most of the flights also travel in this part itself. And stratosphere is a bit higher. We will see in detail, okay, in the coming slides. Okay, mesosphere is most of the space things and all happen. Thermosphere is where your satellites and all are there, and exosphere is more or less the exterior part, and it gets into the space basically from exosphere. Okay, we will see the toposphere. Troposphere is the lowermost layer of the atmosphere, which we are there, no? So above our head is basically troposphere. Okay, its average height is 13 kilometers and extends roughly to a height of 8 kilometers near the poles and about 18 kilometers at the equator. So it is not same all over the earth. Okay, nearby the poles it is the least, almost 8 kilometers, and highest at the equator. Okay, thickness of troposphere is greatest at the equator because heat is transported to great heights by strong convectional currents. We read about the convectional current, the heat, the air movement and the heat movement, right? So because of that heat convectional current itself, it is the greatest at the equator. This layer contains dust particles and water vapor. Okay, this particle, this troposphere, because what we see basically on our head is basically the troposphere. Here only the major part is the dust particles as well as the water vapor. All changes in climate and weather takes place in this layer. Okay, whatever is happening, maybe rainfall or whatever it is because of this layer itself. The temperature in this layer decreases at the rate of 1 degree Celsius for every 165 meters of height. So the temperature is decreasing. Temperature, okay? As you go up, the temperature is decreasing. Okay, this is the most important layer for all biological activity, obviously, because all the major gases are here, the water vapor is here, and most of the biological activity happens in this layer itself. Okay, the temperature as we are going up, the temperature decreases. Okay, the zone separating troposphere from stratosphere is known as tropopause. Okay, between stratosphere and troposphere is the tropopause. The air temperature at the troposphere is about minus 800 degrees Celsius over the equator, and above about minus 450 degrees Celsius over the poles. Okay, the temperature here is nearly constant, and hence it is called the tropopause. Okay, here see the temperature is getting decreased here. Okay, as it is decreasing, I guess it is 80 degrees, not 800 degrees, 80 degrees Celsius and 45 degrees Celsius. Okay, 80 degrees Celsius and 45 degrees Celsius. Okay, as the height is increasing, the temperature is getting lower. Okay, and at this point of time where the tropopause is there, okay, it gets what do we call constant. Okay, it is not going to decrease anymore. Okay, here you can see the troposphere is basically your cumulus clouds, cumulonimbus clouds, and more or less the top of the Everest is in the troposphere itself. Okay, it's just going to touch the tropopause, so it is that huge, this part itself. Okay, even the cirrus clouds, the you will see the clouds in one of the chapter. Okay, what kind of clouds and which are the major clouds, which are and different kind of clouds. And see, this is troposphere and this is stratosphere and this is the tropopause. And the most of the commercial jets, the normal flights which we travel basically are in the troposphere itself. Okay, next comes the stratosphere. It's basically above the troposphere. After the tropopause it is there. Okay, this stratosphere is found above the tropopause and extends up to height of 50 kilometers. One important feature of this stratosphere is that it contains the ozone layer. Okay, the ozone layer is in the stratosphere, one of the very important point. This layer absorbs ultraviolet radiation and shields life on the earth from intense harmful form of energy. Okay, whatever the sunlight is there gets filtered here. Okay, the unwanted very harmful UV rays gets cut down here. The air balloons which a lot of people you can see it in different locations. These air balloons are in the stratosphere. Okay, and most of the fighter jets and all usually travel in stratosphere itself. Okay, next comes the mesosphere. Mesosphere is above the stratosphere basically. Okay, the mesosphere lies above the stratosphere, which extends up to a height of 80 kilometers. You see, stratopause is around 50 kilometers. Okay, so the stratosphere is up to 50 kilometers, and from 50 to 80 kilometers it is the mesosphere. Okay, mesosphere is basically where these satellite things, as well as what do we call any space related things happen basically in the mesosphere. Okay, in this layer the temperature starts decreasing again. See, till now we saw the temperature was stagnant till stratosphere, again it started getting decreasing, okay, and reaches up to minus 100 degrees at the height of 80 kilometers, okay, almost at the top of the mesopause, basically where the mesosphere and thermosphere divide. At the mesopause, it reaches around almost minus 100 degrees Celsius. The upper limit of the mesosphere is known as the mesopause, okay. Here the mesopause is there, okay. Next comes the thermosphere. Thermosphere is very it's between the 80 degrees and 400 degrees, the ionosphere. The ionosphere is basically a part of the thermosphere, okay. It contains electrically charged particles known as ions, and hence it is known as ionosphere. So here in the ionosphere, there are electrically charged particles. Radio waves transmitting from Earth are reflected back to Earth by this layer, okay. So here, for example, we are using some satellite communication, and different kind of radio signals are used, okay. So this happens because of this ionosphere only. Temperature here starts increasing with height. Till now we saw the temperature was decreasing, and now from here onwards the temperature starts increasing. Basically, you will see in the coming slides. I will explain all together in the last, okay. And the exosphere is the highest layer, but very little is known about it, okay. Whatever contents are there, they are extremely rarefied in this layer, okay, and it gradually merges with the outer space. Although all layers of the atmosphere must be exercising influence on us, geographers are concerned with the first two layers of the atmosphere, okay. So basically the first two layers are there, no. So those are very important for the biological activity, as well as whatever most of the phenomenon which happens, basically maybe the climate or the biological conditions or any sort of even a couple of calamities also. This all happens because of those two layers itself, okay. You will see in the detail here. See, this is the temperature line. You see this red line is there, no. This is the temperature line. See, till here you see till the troposphere is there, no. Here it is decreasing, and till tropopause it got very fastly, the dip in the temperature was very rapid, okay. And commercial flights are till here, okay, almost till tropopause, not more than that. But the supersonic planes and jet fighters and all are in the stratosphere, okay. And in the mesosphere, you see the temperature little increased and then again decreased, okay. It was not very huge difference in the stratosphere. Then suddenly there is a dip in the temperature till mesopause, and suddenly the temperature starts increasing very rapidly in the thermosphere stage, okay. And see, Mount Everest is not even till the tropopause, basically, okay. And the clouds and all are basically in the most of the clouds are here also, and these nacreous clouds are here. The ozone layer is here in the stratosphere. Then we see the meteors, okay, and the polar lights which you see basically nearby the polar, the North Pole, basically. You see different kind of lights, basically. Right, in the night time it glows like in the green color kind of glow will be there, okay. That kind of light are in this part, basically the between the thermosphere and the exosphere. And most of the spacecrafts and satellites are in between the thermosphere and the exosphere, okay. Got it. So this parachute jumping and all that is more or less in the troposphere itself. You can't go above this, okay. There will be some sort of issue if you go above it, because oxygen level will be decreasing, okay, and the temperature will be also decreasing very rapidly, okay. So, and those are not the places, or the pressure also changes, okay. The pressure also changes, and because of all this you can't live for a long time there, okay. So this is the same image, the passenger plane is in the troposphere, but the fighter image is in the stratosphere, and this is ozone layer, okay. The high altitude balloons may go till troposphere, but the normal balloons which you see is basically in the troposphere itself. The high altitude balloons are in stratosphere. Meteors and all, they get burnt almost in the mesosphere, okay, and satellite communication and the Hubbles, and these all are in the thermosphere, okay, and after this is more or less space for us, okay. So that's all for today. I hope you find this class useful, and I request you to please like the video and leave a one-liner comment. Let us know how you felt, and please share it with your friends, and subscribe to the channel if you are new, and even if you have subscribed, click on the bell button to get regular updates, and we will start with the chapter number 9 tomorrow. And thank you and have a great day.